And another example. A right triangular plate with legs 2 meters and 3 meters if the aerial density at any point P is 5 H kilogram over meter square, and the H being the distance of P from the shorter leg. Point is 2, 3, and here is H, and also this is LH, and its formula will be y equals to 2 minus 2 over 3x, okay, and the vertical, about this vertical strip, of course, which is del H, and the vertical strip at H has area, which is also del A, okay, equals to 2 minus, okay, 2 over 3H del H, and thus the mass of the plate can be calculated by m equals to integral from 0 to the 3, okay, and the density, which was the delta 0, was 5h, okay, 5h times, and the 2 minus 2 over 3, which is the del A, h, okay, del h, so it equals to 10 times, okay, integral h minus, okay, and the h square over 3 del h, so it's equal to 10 times, okay, h square over 2 minus h cube over 9 from 0 to the 3, and the mass of the plate equal to 15 kilogram, okay, and 10 times, okay, integral from 0 to the 3, okay, and the h square minus h cube over 3 del h, so it equals to 10 times h cube over 3 minus h to the power of 4 over 12, I'm sorry, integral from 0 to the 3, so it's 45 over 2 kilogram meters, and the my 0, it equals to integral from 0 to the 3, okay, and the 1 over 2 times 2 minus 2 over 3 h times h minus 1 over 3 h square del h, and the 10 times integral from 0 to the 3, okay, and the h minus, okay, 2 over 3 h square, and the plus 1 over 9 h cube del h, so 10 times sorry, 10 times h square over 2 minus, okay, 2h cube over 9 plus, okay, and the h to the power of 4 over 36 from 0 to the 3, and the 15 over 2 kilogram meters, and the total mass x bar equals to 45 over 2 over 15, it equals to 3 over 2, and the y bar, it equals to 15 over 2 over 15, it equals to 1 over 2, and the center of mass, okay, at x bar comma y bar, which is equal to 3 over 2 comma 1 over 2. Okay, and now let's talk about the five, and the which is also the centroids. Okay, and the centroid of a standard plane region, we will talk about that. If the center of mass depends only on the shape of the object, and that is on geometric properties of the region occupied by the object, and we call it the centroid of the region, okay, and the centroids can be calculated using the same formulas as those used for centers of mass, okay, which I talked about the previous lectures, except that the density, and this will be being constant, okay, is taken to be unity, so the mass is just the length, area or volume of the region, and the moments will be referred to as moments of the region rather than of any mass occupying the region, okay, and when you set the delta of x, which is the density of the surface, equals to 1 in the formulas, and you will obtain the centroid of standard plane region, okay, let me write this formula. the centroid of the plane region B, and the 0 is less than or equal to y is less than or equal to f of x is x bar comma y bar, where the x bar equals to 0 over a and the y bar equals to m y equals 0 over a, and the a equals to integral from a to the b, okay, and the f of x del x, and mx equals to 0 integral from a to the b, okay, x f of x del x, and the m y equals 0 equals the integral from, and this is the 1 over 2, I'm sorry, equals to 1 over 2 integral, okay, from a to the b, okay, and the f of x square del x. And let's talk about the example. What's the average value of y over the half disk okay, minus a less than or equal to x less than or equal to plus a, and the y is larger than or equal to 0 and less than or equal to square root of a square minus x square, and find the centroid of the half disk, okay, and this is plus a minus a, and the y equals to square root of a square minus x square, okay, and this portion of the half disk will be del x, okay, and any x value. So of course by symmetry the centroid lies on the y-axis, okay, of course the y-axis, but the okay, and the which y value, okay, so x coordinate is, that means x bar equals to 0, okay, and the area of the half disk is easy, okay, which is a equals to, okay, pi times a square and the 1 over 2, okay, and the pi times a square, and the average value of y over the half disk is y bar, it equals to m y equals to 0 over, okay, a, and it equals to 2 over pi a square because of the 1 over a, this is, and the times 1 over 2 times, okay, and the integral, right, from minus a to the plus a, okay, and the a square minus x square del x, and so it's equal to 2 over pi a square and the 2a cube over 3, so it's equal to 4a over 3 pi. And the centroid of the half disk is 0, 4a over 3 pi. And another example, find the centroid of the semicircle, okay, and don't forget previous question, okay, and we are looking for the half disk, okay, that means the half disk contains this area, right? But now we are interested in the semicircle, okay, and so y equals, I'm sorry, y equals the square root of a square minus x square. This is our semicircle. Okay, and the minus a, and again, of course, it will be on the y-axis, okay, and the region is a one-dimensional curve and the having length rather than the area, and of course the x bar equals to 0, and the by symmetry, and the short arc of length del s, which is the here is, okay, and the del s, this is x value and this is y value, and the del s equals square root of 1 plus, okay, del y over del x square del x, so it equals to square root of 1 plus, okay, and the x square over a square minus x square del x, so it's equal to a del x over, okay, square root of a square minus x square. And we know that the y equals to square root of a square minus x square on the semicircle, and we will have the m y equals 0, okay, and the integral from minus a to the plus a, okay, and the square root of a square minus x square times, okay, and the a del x over, okay, square root of a square minus x square, and this part will be cancelled again, and it's equal to a times integral minus a to the plus a del x, so it's equal to 2a square, okay, and the length of the semicircle is 2 pi r. I'm sorry, the length of the circle is 2 pi a, and the length of the semicircle will be pi a. Okay, and we have y bar, it equals to y equals 0 over pi a. Okay, so it's equal to 2a squared over pi a, and the y bar equals to 2a over pi, and the centroid of the semicircle (0, 2a over pi). Okay, and the last part, okay, and the centroid of a triangle. This is also a physics problem, okay, and it's not hard to find this triangle centroids. Okay, x bar, y bar, okay, equals to x1 plus x2 plus x3 over 3, and x1 plus x2, I'm sorry, y1 plus y2 plus y3 over 3, where the centroid of a triangle are the average of the corresponding coordinates of the three vertices of the triangle. Okay, and the x1 y1, x2 y2, and the x3 y3 are three vertices of triangle. Okay, and you can calculate it by this formula, and the example from your book again. Find the centroid of the trapezoid with vertices 0.0, 1.0, 1, 2, and 0, 1. Okay, here is 0.0 and the 0.1, 1.0, okay, and the 1.2. Also this point is 1, 1, I'm sorry, and then we have S and T. S is a square and the T is a triangle. Okay, and the trapezoid is the union of the square and the triangle. Okay, and the both of these shapes are not overlapping to each other. Okay, as you see, and by symmetry the square has centroids, and the XS YS, this is the square centroid, okay, will be 1/2, 1/2. Okay, it's obviously, and of course its area which is the square area, will be, okay, 1, because this is a unit square, and the triangle's area will be 1 over 2, okay, and the xt bar and the yt bar, which is the triangle centroid, okay, and the 0 plus 1 plus 1 over 3, and the comma 1 plus 1 plus 2 comma 3, and it's the 2 over 3 comma 4 over 3. Okay, and they continue to use subscripts, the s and the t, to denote the square and triangle, and we can say mx0 equals to m, okay, s, and the x equals 0 plus mt x equals 0, okay, so a s times x bar s, and the plus a t times x t bars, so 1 times, okay, 1 over 2 plus, okay, and the 1 over 2 times, okay, 2 over 3, so it equals to 5 over 6, and the my0, it equals to m, okay, s y equals 0 plus mt y equals 0, it equals to as times ys bar plus a t times yt bar, okay, so 1 times 1 over 2 plus 1 over 2 times 4 over 3, so it's equal to 7 over 6, and the area, total area, as plus at, so it's equal to 1 plus 1 over 2, which is 3 over 2, and the x bar comma y bar, it equals to, okay, 5 over 6 over 3 over 2 comma, okay, 7 over 6 over 3 over 2, so totally 5 over 9 comma 7 over 9, okay, and now we have just finished the 7.5 subchapter, and the Pappus theorem is omitted, okay, and I have just finished all the courses, which is the Math 193 Calculus 1, okay, so next week, okay, I will not do any lecture, okay, and thank you very much for this semester, okay. I hope I don't want to see you in next semester in the Calculus 1, okay. Thank you very much for your listening, and see you on the other lectures.